Oh, we're live. Hello and welcome back to Clojure, Practicalli Clojure study group. Thank you very much for joining me. My name is John Stevenson. I have been away for a few weeks because I've been ill, unfortunately, but I'm feeling a lot better now. So last time we were looking at Clojure Spec, and we're going to continue that today as well. So we did have a look at the Clojure Spec, just some of the basics, how to define a specification, how to do some validation and check whether something is conforming. And today we're going to look more about the validation, how to use Spec to see if we're calling functions correctly. So checking the arguments and other things that we can do with Spec as well. Before we get started, just a reminder that all the videos and content is on the Practicalli website. Also, I'm sponsored by the Clojurists together, which I greatly appreciate, and so I'm keeping a record of that as well. Just the kind of major updates I'm doing to all the projects I'm working on, and got all the live projects. I've added the particular playlists as well, so it's a lot easier to find the specific content of there. We've got around about 90 plus videos available on the Practicalli channel now, so hopefully these playlists will help you find the content a little bit easier. There's also the books as well, so I've added to the books these shields using this it's really nice, like shields.io website, which will help you just generate like this really nice shield that pulls off information from GitHub or other such services. And so in this case, mine, let's make this a little bit bigger. I've got content ideas, so all the issues I've raised as content ideas, so you can kind of see how those books are developing. So by clicking on one of these, and you can see all the kind of list of issues and things I'm going to add to the particular books as well. And it'll give you an idea about how actively I'm kind of developing that book as well. So the SpaceMax book is fairly complete. I've added a whole bunch of things around using Magit Git client as well just recently. And I've been adding some more things around. So the Practicalli Clojure book is going to be the next one that gets a lot of work as well. If you want to reach out to me, then Clojure Slack community on the Practicalli channel, and there's also lots of really useful channels on there. And you can also keep me motivated by subscribing me or sponsoring me as well. And I greatly appreciate those who keep on sponsoring me. It does make a huge amount of difference, and it's much appreciated. We're nearly up to 500 subscribers on my channel as well, so that's quite nice. We got 475. So thank you everybody for subscribing. Okay, let's get started. So the code we're going to look through is on the Practicalli Leveraging Spec website on the repository, and specifically this spec for validation file. So I uploaded this last night, 11 hours ago, there we go. And so we're all going to walk through this. If you want to look at the previous code that we did, so it was all in the leveraging spec, so we covered like some of the basics, like using a predicate to see whether something conforms to a spec. So we can have a simple spec like is a value conforming to the odd specification. So we can use predicates as specifications, and then we can see if something is valid, which gives a true or false result. And we can use sets to see as predicates as well. And then we start defining some of our specs. So we're going to extend what we did here into the like understanding how the validation works with Clojure Spec. Okay, let's open the right one, spec for validation. There we go. So I've got this project. The dependencies for this was just Clojure itself. So if you have a look at the deps.edn file, then it's just Clojure. I've added this test check for later on. We'll cover some of the test generations, but for just writing specs, then all you need is just Clojure 1.10 or newer. And we've just added this Clojure spec alpha spec in namespace into our namespace, so we can use all the functions in that. And I'm using an alias called spec. And so before we get into kind of like defining specifications for functions, one of the approaches is to actually to use the pre and post conditions that come with the function expression. So you can have a function, you can define like an inline function, an anonymous function, just by doing fn and optionally typing a name and then typing in some arguments, and then you can have it. You can even have the function call itself again, which is why you would use a name. Otherwise, you wouldn't include the name in this function. It would be anonymous. And then you would just do some recursive code in here, or you can just do a simple string and output the args. You probably have to do apply something like that. There we go. Yeah. So we can write a simple function, but we can also add preconditions in here as well. So we can actually define, if we put a map in here, we can do pre and do let's see, let's take this off, sorry, arg, and then we can check to see whether the arg is odd. And if we do, let's see, do a bit of live coding here, and if we do inc arg, we could do a post that checks whether it's odd. And the percent sign is the is that right? Let me check. Yeah, there we go. Sorry, still learning this. Oops, there we go. Yeah, so we can do something that's very simple like that. So we can take in a name. Oh yeah, and then we'd have to wrap this. If we wanted to call this, because it's an anonymous function, we wrap this. So we can call it, and we give it a odd number. No, oops, sorry, that should be even. That makes sense. There we go. Oh, and I've done something wrong there. Very good. Oh. Okay, but that's kind of the general form. So how does this actually work? Let's, I've got an example that does work. Sorry about that. So the example that does work, so we've got this function. This is a specification for defining a function. So we've got optionally, we've got a name. A little bit bigger, there we go. And then we give it some params, and then we've got this condition map. So this condition map is this pre and post conditions, and then we've got the expressions. So that's the kind of the inc or whatever we're doing to the sort of the algorithm of the function that we're defining. And we can have polymorphic expressions. So we can have polymorphic functions by wrapping the parameters in a list. So we get a polymorphic function like this. So here we've got, so this can either be function or defen. they both work the same, because defn is essentially just a wrapper around the fn expression. And so here we've got a function called IamPoly, and if we call it with a single argument, let's jump in around a bit. If we call it with a single argument, then it will do the first branch, it'll do this branch, and if we call it with an argument, so we call it with no arguments, it does this, and we call it with one argument, it does this one. If we call it with more than one argument, then it's going to fail, because well, we could put in an ampersand in there to make as many arguments as we wanted. So if we call IamPoly, why is this not working? Oops. Yep. There we go. If we call this without any arguments, then we get the default value. So it's the default path is just calling IamPoly again, but with a default value for name. And so this line then goes back around and calls IamPoly, but it goes through this branch. So that's your polymorphic things, and to make that work, we put brackets. We put the params into a list. Whereas if we're just doing a single arity, then it's just the params. But in either case, we've got this optional condition map, and we can see it's optional because we put in the specification we put like a question mark at the end to show which things are optional. So the condition map is optional, and the name is optional. And there doesn't seem to be a huge amount of usage of this pre and post condition in Clojure. But it can be quite useful to do some very simple contract checking of a functional contract. So if we're calling the function with the correct values, and so we can do these simple. We can add this map as a pre with a pre expression and a post expression, and these are sort of Boolean expressions like conditionals. So is something odd, is something even. Or we can write our own function that returns a true or false value. And so anything that returns true or false we can use as a pre and post condition. And they will check whatever we want them to check, really. So they're nice and kind of simple approach to do that. And when we're doing the post expression, we can use this percent as a placeholder for the return value. So what the algorithm of the function actually returns, we can take that value and check to see whether it has certain characteristics. No questions so far. Feel free to put any questions into the chat window into YouTube if you have any. Excuse me. I still have a bit of an itchy nose after all my sneezing and coughing. Okay, so here's a simple example that does work instead of my initial example. So we've got a function called number squared, which takes an argument which we're going to want as a number, and then we got the sort of body of our function just multiplies the number with itself. In fact, I'm going to change that to I made that number. There we go. There we go. So we take in a number, we've got a pre and post condition. So the number should be positive. And oh yeah, I missed the square brackets out. That's what I did last time in my other example. So we've got a precondition, and we've got these vectors around our conditions, because we can have more than one condition. So we can have basically a collection of conditions that we want to apply to the in this case to the number, or when we're doing pre, then we're basically testing the kind of the arguments that we're passing into the collection, into the function, sorry. And so we can have a collection of those conditions. So we could also have I think, oh yeah, we do a comma. Pretty sure that comma is not required, but there we go. And then we have a, say we check for it, see if it's an int number. So we can have as many conditions here as makes sense, and then each one will be applied. In this case, to number. So we'll test whether the number is positive and whether it's an integer. And then on the way out, so that's before we do our calculation, and then on the way out we can use a post condition. And again, we've got it in square brackets for a vector. So we've got multiple conditions we're going to apply. In this case, we're saying, well, our calculation should be a number when we calculate the result should be greater than 16 but less than 225. So ideally we probably should put some other conditions in here that states that the number is of a certain size as well, because there's only going to be a certain amount of numbers that we can pass to number squared that will actually make the post condition satisfied as well. But let's stick with that for now. So this is just a normal function. The only difference is we've added this pre and post condition. And if we call number squared with 10, we get an answer of 100, because 100 is between 16 and 225. However, if we call it with a number that's going to generate a value that's not a correct argument, well, in this case, yeah, we're calling number squared and we're not passing in a positive number, we're passing in a negative number. So we've got this Java-like assertion error, and it's basically saying, yeah, the assertion has failed, so the precondition has failed because of this particular condition. So it's specifying which condition is actually failing, and so that gives us a nice clue about the error that has been made when we've been calling this function. So we're calling this function incorrectly. So we've got some nice simple way to guard against calling the function with incorrect data. The same thing for these. So like you can call it with incorrect data. Excuse me a second. And yeah, so we could, I mean, we could also add things in here to like specify like the so it needs to be greater than 4, the number. Is that the right way around? Oh yeah, number 4, there we go. So the number needs to be greater than 4, and so we can also add something like that, less than. So this would also guard against the, this kind of complements what we're doing in the post condition. 16, something like that. I'm not quite sure what the square root of 225 is, so I have to calculate that. But something like that. So we could go and add as many conditions or as few conditions as we wanted to as well. And we don't have to add both of these. We could just add a pre-condition or just a post-condition. Again, it's a map, so these pre and post things are optional. We let's say that in the spec somewhere. No. Oh. oh yeah, so we can have as many of these as we want in there, and they're optional as well. So we can include pre and post if we want to, or just include one of those, or include none of those. So in this case, we've got here, we just want to check the results, make sure we're getting the right kind of result that we want, and so we're not interested in whether it's a positive or negative number, because if you multiply -10 by itself, we'll get a positive number anyway. So these work, but this one still fails because -18 times itself will be more than 225. And apart from doing like more intricate pre and post conditions, then that's kind of the main focus of a pre and post condition. It's very simple. You can add just add predicate functions. There's no kind of big design you need to do, and predicate functions that they're very easy to test them as well. So we can also do we can use like a function call. We can write our own anonymous function in there as well. So any kind of function, any kind of expression that returns true, in fact, would be okay inside the pre or post condition. One of the things about pre and post conditions is it does add more code to the actual function itself. So here, although this is a simple example, we're actually adding a lot more code in the pre and post condition than we are in the actual body of the function. So this might be a reason why people have shied away from this, because you're adding more code to the actual function itself. That does seem to be the only caveat around using these. But I think it's quite a nice way, if you're doing quite defensive programming, is a nice simple way to apply some checks before you actually start doing things as well. So I guess it can simplify, using pre and post conditions can simplify actually the code you need to write in here, because you don't need to check in your actual body of the code to see if a number is positive or if it's an integer. You can actually have some confidence that it's going to be of a certain type that you're going to work with, and you can just go ahead and keep your algorithm quite simple. Okay, so that's pre and post conditions. That's pre and post conditions without spec. So we haven't used Clojure spec at all in this. We haven't needed it. This is just all built-in functionality into the Clojure core. And there's some references here. I'm not going to go through these, but you could do things like aspect-oriented programming with pre and post conditions as well. And there's some other examples and some interesting discussions around that. Yeah, they're not hugely, pre and post conditions are not hugely used. I do know one company that's used them because they had it on their interview test. So it is useful to be kind of aware of them. I think with spec coming out, as people get interested in the spec, then especially when you're doing nested data or more involved data structures, then using spec would be more useful in that regard. So let's have a look, a reminder at spec. So last time I quickly went through a bank account specification. I went through it quite quickly. So we're going to just take an aspect of that. So I'm going to create a customer specification. And this is just a customer, it's like for an online, could be an online bank, could be an online, any kind of online customer. And we're using the specs version of def to define a specification called first name. So we're using a keyword called first name. And this keyword is, it's got the double colon because this is a shorthand way of adding the full domain name to the name. So this is the spec for validation / first name. That's its full qualified name. And the actual specification itself is just testing to see whether something's a string, and the same thing for last name. And then email is also testing for a string, but we're using and to have multiple conditions in here. So all of these conditions need to be true. So it needs to be a string, and it also needs to match this very, very long and quite scary looking regular expression, which I copied from the internet. This allegedly checks to see whether something is an email address in the form of name at domain dot something. I can't guarantee that's completely foolproof, but it's something that I have a play around with. And then so I'm taking these three specifications and then just wrapping them into a customer specification, and I'm doing that just by, so I'm saying that this is a customer, this is a specification called customer, and it's made up of the three other specifications. So, and these are all required. So we need a first name, a last name, and an email address for our customer. And each of those has to satisfy the specification that we've defined in those individual names. And then we can test to see whether that's valid or not. So did I evaluate all these? Yes, I did. Yes, I did. So these are all evaluated. So now I can run the spec valid to check whether the data I'm giving to this customer specification is correct. So is this customer? So this is the customer specification I'm referring to, and is the data conforming? Is it valid data for against the customer spec? And it's true. That's showing true. Oops. Fingers and thumbs. There we go. So true. However, if we have some data that isn't going to be valid, then we can see that it's returning false. So before we do everything in spec, we can actually combine spec with the pre and post conditions. And so therefore we can, because like when we're using valid, it is just returning a true or false. So it is a predicate condition. So we can just use that as a pre or post condition. So let's have a look at that. No questions? No questions. Okay. So we've seen we can use a precondition to check the argument passed to the function. And we want to do that so it makes the customer specification. And then in our particular function, we're going to have this function called customer full name, which is going to take the first and last names from the customer details and just return that as a single string. So we have a post condition that will check to see whether the result is a string. So this is our placeholder for the result, and is it a string? So it's fairly simple pre and post conditions, but it just shows you that you can also use spec with these as well. So evaluate the customer full name, and then we call customer. So we're just calling the function, and with our sample data. And if we evaluate that, then it returns a string with the first and last names. So that's working. When we want it to work, so it's not changing the happy path of calling our functions. We don't have any extra things to deal with. It's just giving us the result. However, when we provide incorrect data, we provide buggy data, then we get a very different story. We get this Java-lang assert error, and we can see here that the assertion has failed. So this is this kind of normal precondition error message, and we're getting, but it's telling us which of the predicate conditions are failing. In this case, it's saying, well, spec valid has failed. So we can see exactly, again, we can see exactly where it's failed. And although we don't get the actual value, so we can see where it's failed, but it doesn't tell us the full story just yet. But at least it gives us an idea about what's actually going on. It gives us a starting point to debug our code. So let's actually break our code in this case. So here I've done same kind of function, more or less. It's almost exactly the same. I've just changed the name, and but I've also introduced a little bug in here because I've changed the string to a print line, and so print line is going to return nil because it sends the string it creates to the standard out to the REPL window. So if I evaluate this and then I call this so now we get an assert fail because it's the output, the return result we are expecting should be a string, but it's not. It's nil because we've changed it to print line. So it does help us catch very quickly the kind of issues that we have. So hopefully that would give us some indication that, oh yeah, it's failing the output. So we'll go and look at our algorithm that we're using, and we'll see, oh, it's a print line. It's not returning a string. So it does help us catch errors in this way as well. But we can also use Spec Assert, which will give us more detailed information about the error. So this is quite handy. So again, I've got the same customer full name, just an assert version. And so I've changed, instead of doing valid, spec valid here, I'm just doing spec assert. Everything else is the same. And evaluate that. The only thing with asserts is you actually need to turn the checking on. It's so Clojure won't check for asserts by default, but you can call this function here called check asserts. Oh, sorry, yeah, called check asserts, and you can set it to true, or you can set it to false. So you can switch it on and off using this function. You can check where it is by doing the check asserts question mark function. So at the moment it's not on because I restarted my REPL before I started this broadcast. So I can switch this on, and now we can see it's on. There we go. So you can actually put this into your dev startup. So if you've got a dev startup profile or a namespace that is the dev or user namespace that does a few things when you start your application up. When you're starting it in a development environment, you can get it to call this check asserts true, or you could even like switch it on and off if you wanted to, based on which profile you were using. So you can check to see whether you're in the dev profile, and then if you are, you can see whether check asserts is on or off, and then you can turn it on if you want. But in order for assert to catch these things, you definitely need to have it switched on. And so now we've got this function evaluated. Yes, we have. And we've got check asserts is on. So now when we call customer full name with assert with some buggy data, then we get more information about the thing that's failed. So this is actually going down into the individual specifications. And this is why it's quite useful to break down your specifications into pieces as well. It helps you track down very specifically where an issue is if you've got a very detailed specification, because you only need to define the specification once, so making it as detailed as possible helps you, especially when you're debugging your code. It gives you a lot more feedback. So here we can see that we got this spec assertions failed. So this is a spec assertion error that's failed. So this is different from the just the precondition error that we got, precondition exception. So this is a Clojure lang exception caused by spec itself. So now we're going into the spec details, and the assert is actually telling us the spec it's using, the value it's using against the spec. So in a much more complex code base, then this is obviously a lot more valuable, because you can see exactly what data is being put into the spec, and then you can see also why these things are actually failing. So it's failing the first name, the last name, and the email address. So I might have data that only fails one of these. So it's telling me not just that the customer has failed, but where specifically in the customer the failure has actually occurred as well. And so if a spec is quite composed quite a large number of other specs, then it helps you narrow down very, very easily to which spec it is that's actually failing. And you've got the value there to compare against. Well, why is that value failing against that particular specification? So you can get as detailed as you actually want to get with spec. Ooh, no questions. And here I'm just doing another spec. And this is just calling this. Yeah, so this is failing on the fact that it's not a map. So this is a much more simple piece of data. So we're still failing on the customer spec. We're giving it the value, and the problem is this is a value and it's not a map. Again, so the results, the information about the error is quite specific, because customer is made up of keys, therefore it also checks to see whether the piece of information it's given is a Clojure hash map, and in this case it's not, so that's where we get the error. So there's no point in checking the other things, because if it's not a map, then it's not going to pass any of the other specifications as well. Cool. What else did we do here? We did another, what did I change here? Oh, and this is doing the print line check as well. So this is going to fail, although we've got the right data, this is going to fail on the post condition. And so I've added an assert to the post condition now. So this will give us a little bit more information on there. In this case, the post condition, as it's using a very simple specification, it's just using the string specification, then that's just returning string. If I had a more detailed kind of specification I was using here, then obviously it would give me more details. But as it's just a simple spec we're using of the string predicate, then that's all the information we get. I hope that makes sense. Okay, where do we go next? Oh, that was an incomplete example. There's some examples in the Clojure spec, but I wasn't quite sure how to get this working. They didn't actually include the spec for this one, so I'm going to skip over that and see if I can work out what the spec actually is. So that's the so using the pre and post conditions actually can be extended by spec, and it kind of does add an extra piece of information. So it's quite a nice kind of bridge to get you into using Spec, and there's nothing. I don't think there's anything wrong with that. I think it's quite a valid approach, especially if your pre and post conditions are quite simple. Then it's kind of a nice check, and it's probably better to do that than not to do that, especially on code that's on the boundaries of your application. You do need to, if you've got your code talking to other systems, other like data sources, then you do need some kind of checking around the data that's coming in and going out. And so pre and post conditions are one approach, Spec is another. You've got things like schema as well. So you've got quite a few things, but it is important to put like a code shield around your boundaries around the API of your code, just to make it more robust. So now we're going to look at Spec by itself. Ooh. So we've kind of wrapped up pre and post conditions for now. So we're just going to look at one of the ways to define a specification for a particular function. So we've seen how to, with the customer, we've seen how to define kind of a specification for data, and then we can check that data as it goes into a functional argument. But we can also write a function, and they'll define a function and write a specification for that function definition, and that uses the Spec fdef function. So we've got a function definition specification, and the one advantage over this that's quite obvious is that you can use this both for functions, so like the fn and defn, and you can also use it for def macro. So from what I can see, looking at the code, def macro doesn't support a conditional map, so it doesn't support the pre and post conditions. So if you wanted to put a spec around your macros, then using Spec would be the appropriate way. You couldn't actually use a conditional map, unfortunately. So fdef, you can define arguments, you can define return type, and you can also define a function that defines a relationship between the arguments and the return value as well. So in that respect, it's also adding more in there. Or the post condition, you can kind of try and encompass that, what the result is. But this is more, the fdef is more specific in saying that you can define the relationship between the two. So this was the example we did from using pre and post conditions. And so if we're going to use Spec and fdef instead, then what we do is we just remove the pre and post conditions, and this keeps our kind of application code very clean. And so so all we've got is just the algorithm that this function actually runs, and we don't have to kind of add lots of kind of metadata and specifications within that function, so it keeps that nice and clean. And then we can define, in this case, we've just got a very simple customer definition, and then we can kind of this kind of checks to see whether the args is a string, and then does it return? Sorry, the args is a customer, and does it return a string? Then we can, when we call that function, then it works just the same. So it's returning just a string jetpack. However, when we call it with bad data, it's actually still returning something. It's not failing. So we have to do something else. We have to instrument, or we have to run like generative testing on this in order to get it to fail, and we'll come to that in a moment. But one thing this does provide is if we go and look at customer full name and go look at the docs for this. So I'm just going to open the Cider doc browser, and so we can see that it's got the doc string in here that we've defined for the there we go. Where's my doc string? There we go. So we've got the doc string I put into the function definition itself, but we've also got the spec definition as well. So when we look at the documentation, we can see what the specification is. So it's adding extra information in here, which I think just by itself is worth writing the specification for, because it makes it very clear what the arguments are. And I've been kind of writing, before I've been doing spec, I've been writing these in the doc string. So I've been typing including arguments and returns section, what they are and what type they're returning, just to kind of help clarify how to actually use a particular function. And so when you're using and reusing functions, then it's very easy to see if you're using them correctly. And there's also links in here to like browser specs, so Cider's giving me links to do that as well, and where they're kind of defined. So it does add extra information about the function definition itself, and which I think just by itself, as I say, it's definitely worth doing just for that. But then we can also instrument it, which we'll have a look at in a minute. So here I've also added more information to the spec, so we can put these as detailed or as simple as we want. So here I'm just doing the args and the return value, just to match the pre and post condition we did. And then in this example, we've got we're also adding a function. So this is defining the relationship between the arguments that come in and the string that goes out. I'm not entirely sure if this is a good example or not, but essentially we're checking the return value and seeing if that is equal to another expression. In this case, we're actually just repeating the code that is actually in the function itself, which seems a bit redundant in this example. There's probably a better way to do this. And again, my function isn't exactly complex. It is just doing a string. So there's not much to kind of add in this respect, but in more complex functions and more complex algorithms, you might want to define a mapping between where you're starting and where you're ending. So the input and the output values that you're getting from your function. And this just adds another, and this also helps kind of check that your algorithm is doing what it's supposed to do in the function. And then if we evaluate that, then yeah, I think that you're kind of supposed to use like spec cat for the arguments list, because they could be multiple ones. And so using spec cat, if you've got to like multiple arguments, then it's very easy to specify one or more items in the arguments list. So here we're picking out the customer details. There's just one argument in there. So that's the name of the argument that's passed to the customer full name function, and we're saying that that should conform to the customer spec. And then we can also put the an and around there as well to do multiple arguments if we want to. Return is the same, and that's we've gone through there. So if we evaluate that and then go and look at the specification, customer full name, then you can see it's added kind of what's called the invariants. So like the something that has to be true from where you start to where you finish. Yeah, so I really like the fact that it's adding a lot of really nice documentation to your specification by default. It's just there, it's just part of the normal Clojure doc function. Okie dokie. But then if we actually want to use that to check something, so we actually got the same kind of results as using pre and post conditions, then we need to take an extra step of one approach is to instrument it. So we're actually just watching the assertion. So I guess this is a bit like turning on the asserts in concept. You're actually saying, I want to specifically watch this function, and you can also instrument like multiple functions. I think the idea is you're going to instrument specific functions, probably all the functions that make up your API, but you're not necessarily going to instrument every single function that you want. It's a bit like tests. You don't necessarily test everything. You'll test the functions that make up your API, but you might not test directly like helper functions, and they will get tested through the fact that you're calling other functions that call those helper functions. The same way with instrument as well. You can test the functions that are your API, and the ones that are like helper functions or just commonly shared ones between functions, they're going to get tested by the other functions calling them. So if we instrument customer full name, so this is basically saying I want to turn the checks on. So when I call customer full name, I want you to do some spec checking to see whether the value is going to match the arguments we're going to pass. And so spec test instrument is just checking the args. It's not checking the other values. There are other functions we can use to check those as well. So we call full name with something that's broken. So some bad data. Now we're getting our error that we wanted, or it's telling us the kind of the real situation. So here again we've got our Clojure lang exception info. So this again is coming from spec itself, in just like we were using, just like we got when we did that last pre and post example. We're getting this spec assertion failed, and this is the regex. So the spec cat we used for the arguments list is a regular expression. So this is why we're getting this spec object that's failing, and we're giving it a value of customer, and then it's defining the problem space. So here we're saying that the value is customer, and it's in at position 1 on the arguments, so we know where it is in the kind of arguments list, and it's failed because it's not a map, and it's failing in the spec customer at customer details. So this is the place where we're testing it, and it's failing there as well. So this gives us a lot of information about what's going wrong, so we can help debug our code when we get errors. And then there's also, I'm going to look at this in another video, but there's things like using generators to actually generate tests for us. So it'll actually generate a range of test cases. In this case, it's generating 100, but I've got an error, something I've done not quite right. So it's generating, by default, it generates like 100 different test cases that it thinks would be useful to run against a particular spec. And so we can have a look at generative testing in another video and go into that step by step as well. But that's another approach which is really powerful, because I think rather than having to struggle to think about what are the appropriate kind of values to put in your unit tests, you can actually get test check to go in and like generate all those values for you without having to write hundreds of lines of code. You can just do spec test check, and it will generate all these different test cases and tell you where it's failing. And I think if we go to the if you go to the spec, have I got that open? I don't think I have that open. Clojure spec. Yeah, so if you go to user guide, in here there's a section on it's like generators. So I'm going to go through this next time. But essentially, you can go in and get it to generate a whole bunch of spec data for you, and it will test all those things for you and show you which things are actually failing. So that's really kind of powerful way to do things. But for now, we can go in and define specifications. We can decide whether we want to use like simple pre and post conditions by themselves, just with normal predicates. We can use pre and post conditions with specs and use spec valid or spec assert. Or we can define, we can just use spec by itself and not use pre and post conditions, and just use a spec fdef to initially provide extra documentation around functions, and then instrument and do testing around that function using the specifications as well. Okay, I hope you found that really useful, and we'll continue. There's a lot more things to look into at Spec, and we'll start doing some more kind of concrete examples, putting things together into an application as well. I did start doing the bank account design, which I'll share, but I haven't quite finished yet. And so it's just walking through this, but I wanted to go through the options for creating a specification for a function before we step through this, because then I can go in and add those specifications for that function on top of this as we define it. So I'm going to share this code base as well. Some of it's kind of similar, but I just walk through kind of putting together, like, because I've separated out customer details and an account holder as well. So I'll share that with us, and then we'll work on this in the coming weeks as well. Okay, well, I hope you found that interesting. Thank you very much for listening. Again, if you want to catch up with what I'm doing, then there's some information on the project updates I'm doing for Clojure Together. I've also got an org journal as well. I'll put a link to that on the webpage. But it's basically showing us what, like, if you want to catch up with what I'm doing every day, then it's all on there when I've pushed it. And yeah, I've got the videos. If you've got any ideas, people have been contributing ideas as well about what they'd like to see in the books. Thank you very much, especially on the Practicalli Clojure one. And I'm going to push sort of like a revised kind of plan of what I'm going to do for each of these books as well. So that should be up over the weekend as well. And yeah, I'm more than happy to have lots and lots of content ideas there, so it gives me lots of things to look at while I'm doing it. And if you want to reach out to me again, just use #Practicalli on the Clojure in Slack, or send me a DM, or email me at john@practical.li if you prefer. Where is it? There we go. Well, thank you very much for listening, and we shall see you next week. Have a wonderful weekend. Thank you. Bye-bye. I need a outro theme. Bye-bye.